Let's look at damped forced motion. A 5-kilogram mass is attached to a spring hanging from the ceiling, causing the springs to stretch 1 meter. Find the spring constant. Sometimes we call this stiffness. How are we going to do that? By Hooke's law. F equals Ky. F is the force applied to the spring, K is the spring constant, and y is the distance that the spring is stretched. Great. Well, how do we find F? How do we find the force that's being applied to the spring? By Newton's second law of motion. F equals ma. M in this case is 5 kilograms, that's the mass, and A is the acceleration due to gravity, which is 9.8. So in these problems, A is always going to be 9.8. Multiply those together and we get 49. So now we know that F equals 49. Plug that into this equation and we end up with 49 equals K times Y, in other words, K times 1. So K is 49 newtons per meter. That's our spring constant. Suppose the damping constant is 42 newton seconds per meter, and the mass is subject to an external force, F of t equals 10 cosine 4t newtons. This could, for example, be a motor attached to the mass. Find the equation of motion of y of t if y of 0 equals 0 and y prime of 0 equals 0. We've seen how to do this before. If we have an object with mass m attached to a spring with spring constant k, and the damping constant for the system is b, then the position y of t of the object satisfies the differential equation my double prime plus by prime plus ky equals 0. This is called free motion. There is no outside force acting on the object. Now that's not what we have here. If there is an outside force, F of t, acting on the object, then we have my double prime plus by prime plus ky equals F of t. F is that force. This is called forced motion. It may be damped. That means B does not equal 0. Or undamped. It means there's no dash pot, no damping, so that B would equal 0. So again, my double prime plus by prime plus ky equals F. We know that the mass is 5 kilograms. The dash pot constant is 42. The spring constant is 49, and the force that's acting on the object is 10 cosine 4t. As we've seen before, the general solution of this differential equation, this non-homogeneous differential equation, is y equals y sub p plus y sub h, where y sub p is one particular solution to the non-homogeneous differential equation, and y sub h is the general solution to the corresponding homogeneous differential equation, my double prime plus by prime plus ky equals 0. Let's find the solution y sub h to the corresponding homogeneous equation 5y double prime plus 42y prime plus 49y equals 0. We've seen how to do this. Okay. We write this as 5r squared plus 42r plus 49 equals 0, which factors nicely. 5r plus 7, r plus 7 equals 0. So in other words, r equals negative 7/5, or r equals negative 7. So the solution to this homogeneous differential equation is y equals c1 e to the negative 7t over 5 plus c2 e to the negative 7t. Now let's find a particular solution to the non-homogeneous differential equation 5y double prime plus 42y prime plus 49y equals 10 cosine 4t. We let y equal a cosine 4t plus b sine 4t. That's going to be our guess because we have a constant times cosine 4t on the right side. This is going to be our y. This is our y prime. We take the derivative, we get negative 4a sine 4t plus 4b cosine 4t. Take the derivative of that, and we get negative 16a cosine 4t minus 16b sine 4t. We're going to plug all of that into this differential equation so that we get 5y double prime plus 42y prime plus 49y equals 10 cosine 4t. Now we multiply out the left side, and we end up with this big, messy equation. Let's compare coefficients of cosine and sine. So we have cosine 4t times negative 80a plus 168b plus 49a. Okay, so we got all that stuff. Cosine 4t times that equals 10 cosine 4t. Simplify that by dividing both sides by cosine 4t, and we end up with this. Negative 80a plus 168b plus 49a equals 10. In other words, after simplification, negative 31a plus 168b equals 10. Awesome. Let's do the same thing for sine. For sine, the coefficient on the left side is negative 80b minus 168a plus 49b. The coefficient on the right side, okay, and that's what leads to this over here. The coefficient on the right side is 0 because there's no sine 4t on the right side over here. So dividing both sides by sine 4t, we end up with this, or in other words, negative 168a minus 31b equals 0. Okay, so now we have a system of equations. The solution to the system of equations is horrendous. A equals negative 62 over 5837, B equals 336 over 5837. So this leads to our particular solution to the differential equation. Awesome. The general solution of the non-homogeneous differential equation will be y equals y sub p plus y sub h. So again, it's going to be the particular solution to the non-homogeneous differential equation plus the general solution to the homogeneous differential equation, the corresponding homogeneous differential equation. That's our y. Now let's plug in the initial values so we can determine the values of c1 and c2. So we have y of 0 equals 0, y prime of 0 equals 0. Again, it's an initial value problem, so we can figure out what c1 and c2 are. Here's the equation we're working with, or the function. When we plug in t equals 0, this is what we end up with. Cosine 0 simplifies nicely, that's 1. Sine 0 simplifies nicely, that's 0. E to the 0 is 1, e to the 0 is 1. So this equation simplifies to negative 62 over 5837 plus c1 plus c2 equals 0. In other words, c1 plus c2 equals 62 over 5837. Let's do the same thing with y prime. Here's y. Take the derivative, and we end up with this. Oh my goodness, what a mess. But that's what you get when you take the derivative of the above equation. That simplifies to 248 over 5837 sine 4t plus 1344, blah, 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 blah. Plug in 0. Again, sine 0 is 0, cosine 0 is 1, e to the 0 is 1, e to the 0 is 1. And we end up with 1344 over 5837 minus 7/5 c1 minus 7c2 equals 0. Move this 1344 over 5837 to the other side, and we end up with this. So we have a system of equations. Okay, that's what it looks like. The solution is c1 equals negative 25 over 898, c2 equals 126, and so this is our final answer. So that's the solution to the non-homogeneous initial value problem. Let's graph the solution. Looks kind of weird because it looks, it looks like a sine curve here, but for some reason it's lower here, and for some reason it's lower here. Something weird is happening. We'll show you in a moment what's happening. Find the steady state solution and the transient solution. Okay, the steady state solution is going to be this part of the solution, and the transient solution is going to be this part of the solution. Why? Well, it's because this part over here is essentially the negative 62 over 5837 cosine 4t, blah, 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 blah. And this part over here, that's what's dragging down, the function over here. More precisely, the transient solution approaches 0 as t approaches infinity. And so it's going to be of the form e times e to some negative constant times t times f of t, where f of t may be constant or sine or cosine or a polynomial. So this part over here, that's going to be our transient solution. In other words, our transient term. It's e to some negative constant times t times some function f of t, which is constant or a polynomial or sine or cosine. Same thing here. E to some negative constant times t times a constant or sine or cosine or a polynomial. That's our transient solution. The steady state solution is periodic, so it's going to be a sine or cosine function, and that's basically what we have over here. That's the rest of it. That's our steady state function. Find the amplitude and frequency of the steady state solution. Okay? So here's our steady state solution. We've seen that the amplitude of y equals a cosine omega t plus b sine omega t is the square root of a squared plus b squared. So that's our amplitude. Now in this case, a is negative 62 over 5837, and b is 336 over 5837. So this is what the square root of a squared plus b squared looks like. Simplifies to this, square root of 20 over 5837, or roughly 0.0585. The frequency is going to be omega over 2 pi. What's omega? Again, a cosine omega b plus b sine omega t. You can see that omega in this problem is going to be 4. So omega over 2 pi is 4 over 2 pi, which is 2 over pi. Suppose a 2 kilogram mass is attached to the spring. Find the equilibrium displacement. So again, by Hooke's law, F equals ky, which is 49y for this particular spring. That's the spring constant. Now by Newton's second law of motion, F equals ma. M, the mass, is 2 kilograms. A is the acceleration due to gravity. That's 9.8. That multiplies together to give you 19.6. So we're going to plug this in for F. Okay? And we end up with, basically we end up with y equals 19.6 over 49. In other words, 0.4 meter. That's how much the spring ends up getting stretched.